In this part of the presentation, we discuss catalysts and how catalysts influence activation energies. Catalysts, you recall, are substances that change the rate of reaction without themselves being used up in the reaction. So a catalyst is present before a reaction takes place and after the reaction takes place. We can think, when we follow the energy profile of a reaction, we can think of a catalyst as something that will give us a different pathway for the reaction with a different energy profile, but you should notice that the starting point for the catalyzed and uncatalyzed reaction and the ending point for the catalyzed and uncatalyzed reaction, the starting points and the ending points are the same. We have the same energy, whether at the beginning of the reaction and at the end of the reaction, whether the reaction is catalyzed or uncatalyzed. The catalyst only affects the means by which we get from reactant to product. So we say they change the mechanism by which the reaction occurs, but it does not change the overall reaction. And this is something that will become important when we discuss equilibrium. In this chapter, there are three types of catalysts that are discussed: homogeneous catalysts, heterogeneous catalysts, and a special category for biological molecules called enzymes. Homogeneous catalysts are simply things that are mixed with the reactants in a homogeneous solution. And the concentration of those catalysts can influence the reaction as well as the concentrations of the reactants. And ordinarily, the greater the concentration of the catalyst, the faster the reaction. And so the important thing about homogeneous catalysts is that the reactants and the catalyst are in the same phase. And ordinarily, they're dissolved in the same solvent. A heterogeneous catalyst, on the other hand, is something where the catalyst is in a different phase than the reacting molecules. An example of that, it's a very common example, is many metals are used as catalysts for gas phase reactions, and this is the thing that happens inside the catalytic converter of your car, where nitrogen oxides react with or are catalyzed by a metal to split into nitrogen and oxygen. And that's called heterogeneous because we don't have a homogeneous mixture between the catalyst and the reacting substances. So the catalyst is in a different phase than the reactants, and the examples of gases passed over a solid catalyst. And in this example, we see the molecules are first absorbed onto a metal surface. They react on the metal surface here, and then the product molecule leaves, leaving the surface the way it was before. So the surface is a true catalyst. It is not changed in the reaction, but it definitely influences the rate, and it's heterogeneous because it's not mixed with the reactants. There's a special category of catalysts called enzymes. I'm sure you've heard of these from biology class. An enzyme is something that is catalyst for very specific biological reactions. So we say enzymes are biological catalysts. Every enzyme catalyzes a very, very specific biological reaction and nothing else. A couple of points of terminology. On an enzyme, the part of the enzyme where the reacting molecules attach is called the active site. And another part of the point of vocabulary is that the reactants in an enzyme catalyzed reaction are called substrates. shows kind of a general model called it's got a lock and key model for how biological catalysts called enzymes work. The enzyme we see here has there's some particular shape on the molecule. I'm circling it here, that fits only one particular kind of substrate. So there's a particular kind of molecule whose reaction is catalyzed by this particular enzyme. And only that substrate fits neatly into the enzyme. So the substrate comes along and forms an enzyme substrate complex, shown here, and then the enzyme causes a reaction to take place. In this case, in the particular example here, the catalyzed reaction is one that splits this molecule into pieces. And so the products shown here leave the enzyme substrate complex, and again the enzyme remains unchanged, which is characteristic of catalysts. Okay, and we say that in the enzyme substrate model, the substrate fits into the active site. It's very similar to the way a key fits into a lock, and only one particular key fits that lock. And that means that that enzymes are specific for every kind of reaction. Every specific kind of biological reaction that's enzyme catalyzed has its own enzyme.